Welcome to the class. Today topic is particle nature of electromagnetic radiation, Planck quantum theory. Before we going to this concept, in previous class we know electromagnetic radiation has dual character or dual nature. Okay, on that context, electromagnetic radiation has wave-like motion or wave nature. Okay, why we say it has wave nature? Okay, because electromagnetic radiation can show interference and diffraction. So then it is called it as electromagnetic radiation shows wave nature, like wave-like properties. Okay, because of those two terms, electromagnetic radiation has wave nature, then we say that electromagnetic radiation has wave-like nature, because of they show interference and diffraction. Interference and diffraction Okay, because of these two properties, electromagnetic radiation can show interference and diffraction. So if any radiation shows interference and diffraction, then that electromagnetic radiation has wave-like properties. Then we call it as that electromagnetic radiation has wave nature properties. What is the means of interference? Interference means this is we take a wave and another wave, then mixing these two, there are two possibilities. This is known as interference. This is not constructive interference. Waves are constructive. One is mixed with the same phase. One wave is mixed with the another wave with the same phase. Then it is known as constructive interference. Constructive interference. If these two are mixed together in out phase, then it is known as out phase means this one and this one. This is known as destructive interference. Destructive interference. Okay, this is the way interference occurs. Next, what is the means of diffraction? Diffraction means bending of light, bending of the wave. Okay, when it strikes on any surface, it shows bending nature. Then bending of light is known as diffraction. If any radiation shows interference and diffraction, then we call it as that radiation has wave-like properties. Okay, particle nature of electromagnetic radiation. Particle nature of electromagnetic radiation, Planck quantum theory. Okay, what it says. Okay, let us focus this concept. Okay, what is the means of Planck quantum theory and what is the meaning of particle nature of electromagnetic radiation? Okay, let us look into these topics. Okay, why? Okay, particle nature of electromagnetic radiation, Planck quantum theory. Okay, electromagnetic radiation does not electromagnetic radiation, we know electromagnetic radiation has wave nature. Okay, electromagnetic radiation from the previous history. From the previous history, we know electromagnetic radiation has wave nature. Okay, with the concept of wave nature, it cannot explain these type of experiment results. So, what are the experiments? The nature of emission of radiation from the hot bodies. The nature of emission of radiation from hot bodies, that is black body radiation. Black body radiation concept is not explained by the wave nature of the electromagnetic radiation. Is not explained by the wave nature of the electromagnetic radiation. And also ejection of electrons from the metal surface when radiation strikes it. That is known as photoelectric effect. This type of practical is also not explained by the wave nature of the electromagnetic radiation. And then variation of heat capacity of solids as function of temperature. This type of experiment also is not explained by the wave nature of electromagnetic radiation. So, it is the another way means particle nature of electromagnetic radiation is introduced by the Planck quantum. Okay, particle nature of electromagnetic radiation is introduced by the Planck quantum. Planck quantum has assumed electromagnetic wave has particle nature. With this concept, he was succeeded to explain nature of emission of radiation from hot bodies. Okay, and then ejection of electrons from the metal surface, and then this one. Okay, these three practicals are explained by the theory of Planck quantum theory. Okay, Planck quantum theory is based on particle nature of electromagnetic radiation. Okay, he was succeed to explain these practicals, but the classical way means wave nature of electromagnetic radiation does not explain these these experimental data. Okay, these experiments are not explained by the wave nature of the electromagnetic radiation, and this theory, these practicals are explained by the particle nature of electromagnetic radiation is introduced by the Planck quantum. Okay, let us look into this concept in detail. What is what and what is the main object? Okay, how he was succeeded to explain nature of the emission of the radiation from hot bodies, and next ejection of the electrons from metal surface. Okay, in atomic structure concept, we only consider these two concepts. We can explain one by one the nature of emission of radiation from hot bodies. Then we go to this one. These two are in our syllabus. We only focus these two concepts, experimental details, in detailed explanation in this atomic structure concept. Okay, this is not present in our syllabus. We may in our syllabus there are two topics are covered in detail: the nature of emission of the radiation, black body radiation, and ejection of the electrons from metal surface, means photoelectric effect. Okay, let us focus. Okay, in 10th class textbook also there is one concept, that is, if we take a metal rod, when we take a iron rod, suppose taken as a iron rod, if we take a iron rod and heated it, then heated up, then it color changes to initially it is in red color, okay, red color, and then it may changes to orange, and then if you heat continuously, then it changes to white, and then again you can heat, more heat can pass through this one, it can turn into blue color. It turns into blue color. Okay. The experiment is when you take an iron rod, is heated up, then initially it becomes red and then it turns to orange, and then after some time, after heating, goes on heating, it goes to white color, and further heating you can get the blue color of the metal. Okay. What it indicates? It means why we are seeing orange color, red color, white color and blue color. Okay, because if you eat the any metal rod, any iron rod, suppose it has a metal iron rod, and on heating it can emit the radiation, which can emit the radiation. The emitting radiation has red color. Okay, radiation has red color, and then if you heat, if you given the more amount of temperature, more amount of heat, okay, temperature or heat, if you are given the higher heat, then it appears the orange color. Then if you more heat you can supply, then it can turns into white, and then it simultaneously turns into blue. Okay. What do we understand? The metal emits red color radiation. Here, after some time, on again continuous heating, it can emit the orange color, and then white color, and then it emits the blue color. Okay, blue color radiation. So temperature increases. What we understand? Temperature, when temperature increases, okay, temperature increases, okay, wavelength, temperature increases, wavelength decreases. Wavelength decreases, temperature increases, wavelength decreases. Okay, this has, red light has longer wavelength. Okay, orange, white, it has shorter wavelength, longer wavelength to shorter wavelength. We know from the previous electromagnetic spectrum. Okay, which color has greater wavelength, which color has shorter wavelength. So temperature increases, wavelength decreases. Okay, from this point of view, we know temperature increases, lambda decreases. Okay, lambda value decreases. Lambda value for blue color is very low. Then compared to red value, red color has greater lambda value. And then we also know from this experiment, temperature increases, then intensity is also increases. Intense means intensity. Intense means brightness. Okay, brightness is also increases. Temperature increases, intensity is also increases. Okay, intensity is also increases. Okay, wavelength decreases and intensity increases. Intense colors. Okay, intensity is increases. Temperature increases, intensity is also increases. From this point of view, you can understand these two. Okay, from this experiment, an iron rod heating, it becomes to, initially it is red, and then again on heating you can get the orange color, and again on heating you can get the white color, and again on heating you can get the blue color. Okay, blue color. Okay, from this point of view, temperature increases, lambda value decreases, and then temperature increases, intensity of the radiation is also increases. Okay, we may have some questions or doubts regarding this one. Is if you observe red color initially, then you may have some doubts. Okay, only red color radiation will come out of the metal rod? Okay, no. Okay, no. Why we say that? There are innumerable number of radiations will come on heating. Any metal on heating, initially it shows the red color. Okay, initially shows the red color. The metal has different radiation which emits the different types of radiations, red color, blue color, whatever may be the colors. But the dominated color is red color. Okay, one color is dominated, one color is intensified. That is the red color. Okay, initially if you are starting to heating a certain metal, it can emit so many radiations. But red color is a dominated one. Then we can call it as a metal initially shows the red color. And then after some time you may again heating, you may observe orange color. Shall we call it as a metal can shows only orange color radiation? It can emit only orange color radiation? No, it can emit so many radiation, blue color, red color, white color, whatever it may be. But the orange color here is the dominated one. The dominated one will be, you can observe. Okay. You may take any other example for this one. Okay, dominated personality will be focused. Okay, remaining will be drop out or fade out. Okay, if you take milk and add some more bananas or apple or whatever may be the pieces, you can add for the milk juice or like that. Okay, if you had more apples, then the flavor is apple flavor. Okay, that is the reason why the more intense color is orange, so we can appear the orange color. That is the same way here also. Here also the blue color is the dominated one. Remaining colors will be fade out and very little, and then the blue color is intense because it has the more dominated one. That is the reason after greater heating you can get the blue color. Okay, this is the point of view you can understand. Next, what is the means of black body? Okay, black body is a imaginary concept. Black body is not an exist, it is an imaginary concept. What is the means of black body? Black body, okay, I may write like this. Black body in platinum metal, take it as a platinum metal, is coated with carbon black. Okay, platinum metal is coated with carbon black, carbon C-A-R-B-A-N, carbon black is coated, is C-O-A-T-E-D, coated and platinum. Okay, platinum. What is the importance of black body? Black body is an imaginary one which cannot be exist reality. Okay, which can absorb all the radiation. If you pass any radiation, that radiation will strike here and then it will goes like this, and perfectly it is absorbed here. Any radiation can pass through this body, it is absorbed totally. And then if you heat this one, whenever you heat the black body, it can emit all the radiation which is absorbed previously. Okay, which is the perfect body which can absorb the radiation, and simultaneously on heating it can emit the radiation. Okay, that is the importance of the black body. Okay, that is the importance of the black body. Okay, let us explain one graph. This is very important for the Planck quantum theory concept. Okay, this is an experiment. In this experiment, they are taken intensity in y axis and lambda in x axis. Okay, in this regarding, at lower temperature, intensity of the radiation increases. For a black body, if you are taking black body concept, at lower temperature, intensity of the radiation, emitted radiation is emitted or absorption. But if you are taking it is emitted radiation, black body radiation. Okay, at T1 temperature, intensity of the radiation increases. Intensity reaches to the maximum and then starts to decreases. Okay, so intensity increases with decreasing lambda. Lambda goes to the lower value, shorter lambda value, and reaches the maximum and then starts decreases. If you increase higher temperature for a black body, then it is also intensity increases and reaches to the maximum, and then starts intensity decreases, and the lambda maximum goes to the shorter wavelength. Then compared to this one, it goes to the shorter wavelength. Lambda maximum goes to shorter wavelength. And if you take another temperature, it is very higher temperature. T3 is greater than T2 than T1. So T2 is higher temperature, and then T3 is very high temperature. Then also intensity of the radiation increases and then starts decreases, and it moves to left hand side. Lambda maximum moves to the left hand side. Okay, temperature. If from this graph we can understand that temperature is inversely relation to lambda. This is Wien's law. Okay, which is, you may read it in physics. Okay, temperature and lambda are inversely proportional. Okay, at lower temperature, this is the lambda. If you increase the temperature, lambda value decreases, and further increases, lambda value further decreases. Okay, this is the way you can found initially. We know if you start an iron rod, then temperature increases from red to, it turns to initially red and then white and then orange, then white and then blue color changes. Okay, which is also increases. Temperature increases, lambda value decreases, and then from that point of view, you may know temperature increases, intensity is also increases. Intensity, what is means of intensity? Intensity means thickness or brightness. Okay, brightness is known as intense color. Okay, pale red, intense bright red. Okay, what does it mean? Bright red means intensity is increases. Okay, that is the reason why intensity means what is the means of intensity is brightness. Okay, brightness of that color is known as intensity. Okay, let us explain this one. This is the practical experiments data. Comes from the practical. Okay, from the practical data which is not explained by the wave nature of the particle. This practical data is not explained by the wave nature of the electromagnetic radiation. This practical data cannot be explained by wave nature of the electromagnetic radiation. So then a new concept is derived by Planck quantum theory. This is known as Planck quantum theory. Okay, he can explain this concept. He assumed the radiant energy emitted or absorbed by a body not continuous but discontinuous. Okay, discontinuously in the small discrete packets of energy, and these packets are called quantum. Okay, the first statement itself is indicate this theory. The radiant energy emitted or absorbed by a body. Okay, radiant energy is absorbed by a body, not continuous but discontinuously in the small discrete packet of energy. These packets are called quantum. If you hit the black body, then it can emit the radiation in discrete. Okay, discrete means packets of energy, not continuous wave. Okay, it seems to be wave, but it is packets. Okay, it has packets of energy. Okay, packets of energy. Okay, but it seems to be wave nature, but it is packets of energy. Okay, packets of energy. It's known as packets of energy. Okay, radiant energy emitted or absorbed by a body, not continuous but discontinuous in these small discrete packets of energy. These packets are called as quantum. Okay, if you increase the temperature of a black body at lower temperature, T1 temperature, it can emit the radiation. It means whenever intensity increases, means goes to from this side, intensity increases means number of packets increases. Number of packets of energy emitted energies increases. Okay, number of packets increases, the energy of each packet is also increases. These are 2 points. The number of intensity is increases because number of packets, emitted packets are increases. Number of packets comes from the light or increases. Okay, number of packets increases and each packet energy is also increases. That is the reason why you can get the lambda maximum. Lambda maximum means highest intensity at this temperature, and then downs. The intensity of packets or decreases, then it falls. So if we increase the temperature, intensity of the radiation increases means it emits the number of packets are increases. Why intensity increases means number of packets increases and each packet energy is also increases. That is the reason number of packets are increases, goes on, temperature increases, number of packets are increases. Okay, energy of the each packet is also increases and then reaches maximum and then shortly decreases. Okay, this is also same thing. Okay, when you increase the further increase of the temperature, so why intensity is very high? Because number of packets of energy is increases and each packet energy is also increases. That is the reason why, and then it is sharply decreases. So in this concept, this practical data is explained by Planck quantum theory in this way. Okay, we know temperature increases, intensity of light is also emitted or absorbed radiation is also increases. Temperature increases, intensity of the intensity is also increases. Temperature increases, lambda decreases, and temperature increases, intensity is also increases. Intensity also increases when increasing the temperature, because number of quanta, number of packets This means packets are called quantum, okay, known as quantum. Number of quantums are increases. So that is a reason why intensity is increases. Okay, this is the way he can explain particle nature of the electromagnetic radiation. So packets, okay, here it's not continuous wave. The emitted radiation is not a continuous wave. It has a packets of energy. Okay, the wave has contained packets of energy. If the packets are increases, the wave packets, energy of the packets in a particular wave, energy of packets is there. The energy of the packets are increases and number of packets are increases, then intensity of the color is also increases. Okay, you may see any color in VIBGOR. Okay, red color, you know, light red and dark red. Dark red is intense. Intense means number of packets of energy, number of packets are increases, but each packet energy is also higher than compared to the pale red. So in this way you can understand this in a better way. Okay, which is also useful for the physics. Okay, theory which is present in chemistry and which is also present in the physics also. Okay, Planck quantum theory which is also reappears in second year physics, but in first year chemistry, in atomic structure we may learn Planck quantum theory. Okay, which is present in first year chemistry and second year physics. Okay, same concept will appear twice. So if you understand better way in first year, then no need to bother about second year physics. We can understand this concept very easily. Okay, next, second point. In case of light, the smallest packet of energy is called photon. Small packet of energy in case of light energy, you may call it as, in case of light, the smallest packet of energy is known as photon. Small packet in case of light is known as photon, but in general case, smallest packet of energy is called as, smallest packet of energy is known as quantum. In general case it is called as quantum, but in case of light it is known as photon. Okay, photon of light, okay, means packet of energy. Okay, these two and very important points, and there are some more points. We look into this one, and then two more points is present in this in this. Okay, let us say this one. After seeing this, after understanding of these 2 points, then Planck quantum has another 2 points. Okay, the energy of each quantum is directly proportional to frequency of the radiation. Energy of the each quantum, each packet energy of the each packet, energy of the each packet is directly, energy of the each quantum is directly proportional to frequency of the radiation. Energy of the each packet is directly proportional to frequency of the radiation. Frequency, this is known as frequency, nu. Okay, nu is frequency. Okay, frequency. Okay, next, the H means constant. This is known as Planck constant. H is equal to 6.625 into 10 whole to the power of minus 34 joules per second, joules second. Okay, joules second. Okay, next point, total amount of energy transmitted from one body to another will be some integral multiple of energy of quantum. Okay, total energy transmitted E is equal to n into h mu. Okay, there is multiple number of quantums are present. If the total energy contains number of packets of energy, okay, one packet energy is this one, E is equal to h mu. The relation of one packet of energy is like this. There are, if the light has so many packets, then you can apply this one, E is equal to NH nu. Okay, for total amount of radiation emitted. For that one, okay, there is no number of quantums are present. Okay, in this way, E is equal to NH mu. N is an integer and N is number of quantum. Okay, this is the way you can understand better this concept. Okay, anything is clear? Let us look into these two problems. One of the problem says, how many photons of light having wavelength of 5000 angstrom are necessary to provide 1 joule of energy. Okay, they ask you how many photons of light having wavelength 5000 angstrom minutes necessary to provide 1 joule of energy. Okay, means you can use this one, E is equal to NH mu. Number of photons they ask you. Energy they have given, number of photons. Okay, N you required, N is equal to E by H mu. Nu is equal to C by lambda. H is Planck constant, C by lambda. Then lambda goes to this one, you can write like this, and then lambda value 5000 10 to the power of minus 10 meters by Planck constant value into C value 3 into 10 to the power of 8 meters second inverse. From that you can get 2.5 into 10 to the power of 18 photons. Okay. Next, calculate energy of photon of wavelength 4000 angstrom units. Okay. Here they ask you energy of a one photon. Okay, energy of one photon is equal to formula, energy of one photon formula is equal to h mu. Okay, you can calculate H and C by lambda. H is constant, C is also constant, then lambda value is 4000 into 10 to the power of minus 10. These two are constants, these values are fixed. H value is always fixed, joules 6.626 into 10 to the power of minus 34 joules second. Okay, C value is also fixed, 3 into 10 to the power of 8 meters second inverse. 8 meters second inverse. So this is also fixed and gives us the 4.96 into 10 to the power of minus 19. From these two problems, why I am saying these two problems, you can calculate one photon energy, and then also you can calculate number of photons in this way. In this way you can calculate one photon energy, one photon wavelengths. In this you can use for this, you can use this formula. You want to know how many photons are present, then you can use this formula. Okay, thank you.